Hey Chemistry, Mrs. KJ here, going over 3.06 nonmetals. Nonmetals are located on the right side of the periodic table. In this lesson, you will learn about nonmetals. You will explore where these elements are located on the periodic table, what properties you might expect a nonmetal to have, and a few examples of specific nonmetals. Goals for this lesson: locate nonmetals on the periodic table, give some examples of nonmetals, describe properties of nonmetals. So periodic table groups some elements as nonmetals. Remember, there are also metals, which we talked about, and there's metalloids, which we will talk about. Properties: dull, not malleable. In other words, you can't hammer them into shapes. Not ductile. In other words, you can't make them into wires. Do not conduct heat and electricity. Where they're located is the right third of the table, so kind of up in this corner, except for hydrogen, which is up in the top left. You can download the study guide if you want it. So here are nonmetals. They are located on the right side of the periodic table, as well as hydrogen. So the nonmetals except hydrogen are found on the right side of the periodic table, and hydrogen is over here in column 1. Why? Because it has one valence electron. There are 17 elements that are nonmetals, which is much less than the number of metals. However, nonmetals are very important and make up much of the Earth's crust, atmosphere, and oceans. As you can see, the nonmetals, except for hydrogen, are found on the right side of the periodic table. Some chemists classify hydrogen as a nonmetal, while others place it in a class all by itself. In this class, we go with the fact that it is a nonmetal. Nonmetals are typically defined by what they are not. Whereas metals share many properties such as malleability, conductivity, and ductility, the nonmetals do not share these properties. Nonmetals tend to be poor conductors. They are not shiny and hard in their elemental form, but tend to be rather brittle or dull when in solid form. Their densities, boiling points, and melting points are much lower than those of metals. Nonmetals tend to have high electronegativities. So high electronegativity means that what? It really wants to get an electron. And when we talk about the fact that they have low melting and boiling points, think about oxygen. The oxygen you are breathing in right now is a gas. That means it already boiled. Yeah, think about that for a second. So boiling does not mean hot. Boiling just means how much energy it takes for a substance to change from liquid to gas. And the air around you has already boiled. So even when you go outside and it's negative 80 degrees, that air has been boiled because it's a gas. Fluorine has the highest electronegativity of any compound and is highly reactive in seeking to gain an electron. But the lack of defining properties for this group of elements does not mean that they are insignificant. The rocks around you are composed primarily of oxygen and silicon. Earth's atmosphere is approximately 78% nitrogen, 21% oxygen, and 1% argon, carbon-containing gases, and other gases. And living things are composed of carbon. Nonmetals are very important. The Earth's atmosphere is mostly composed of two elements, oxygen and nitrogen, and then of course there's the other gases, including carbon dioxide, helium, hydrogen, krypton, methane, ozone, and sulfur dioxide. Ozone is O3, so 3 oxygen atoms combined. When they say oxygen here, they mean O2, which is the form that your body uses. Some chemists classify the noble gases as nonmetals, which we will for this class. The noble gases, helium, neon, argon, krypton, xenon, and radon, are often classified as nonmetals. They are located in group 8A on the periodic table, which, if we look at our periodic table, it's the group way at the end. Noble gases almost never enter into chemical reactions under normal conditions. Their outer orbitals are full, and their valence electrons resist entering into chemical reactions. Because they have a full outer shell, they are stable. They have 8 electrons in their outermost energy level, except for helium, which has 2, and that gives it its full outer shell. Remember, the reason helium only needs 2 is because it's so tiny, it only has that one orbital, and the first orbital fills up after you have 2 electrons, whereas the other orbitals take 8 to fill up. Noble gases differ from other nonmetals, which are much more reactive. Neon gas is used heavily in neon signs, although other noble gases are used to provide different colors and effects. So let's talk about a specific nonmetal, fluorine. Fluorine is a halogen. All right, so halogens are group 7A. Fluorine is a halogen that is highly reactive nonmetal. Fluorine is a nonmetal, a halogen from group 7A. Elemental fluorine, F2, is a poisonous gas. It is pale yellow in color and can cause serious burns if it comes in contact with the skin. As a member of group 7A, fluorine is one electron away from having a complete outer shell. This means that fluorine is most stable as an anion with a charge of -1, or in other words, F negative. So fluorine really wants that last electron to have a full outer shell, which means it has the highest electronegativity of any atom, and therefore it's not going to be stable until it gets that electron, which gives it a -1 charge because it has one extra electron. Fluorine readily combines with the alkali metals, which easily donate a single electron to the halogens. Lithium fluoride, LiF, is a common compound formed from fluorine. It is white crystalline compound used in ultraviolet technology. Fluorine, most often as hexafluorosilicate, okay, I'm not going to redo that only to show you that when you say these, you got to break it into parts. So it's hexafluorosilic. There we go, I have to make that a soft C. So hexafluorosilicic acid, which is H2SiF6, is an additive in toothpaste and drinking water. The fluoride ions aid in the remineralization of teeth and thus help prevent tooth decay. So it's not a poisonous gas anymore because it's combined with hydrogen and silicon. All right, so then the other thing that they mentioned was the halogens, because they want one electron so badly, they're going to combine easily with the alkali metals, because why? They have one valence electron that they really want to get rid of. So it makes everybody happy. Chlorine is a halogen metal that is very reactive. The nonmetal chlorine is in group 7A and is a halogen. Halogens need just one electron to make their outer shells complete. As a result, they react readily with other elements, in particular the alkali metals in group 1A. So again, the halides are going to very easily react with the alkali metals. They react with other stuff too, but super easy since they want to lose one, they want to gain one. It's very easy. As an element, chlorine, Cl2, is a dense green poisonous gas. Here's some chlorine. However, chlorine readily forms bonds with sodium, Na. Sodium reacts violently when placed in water and starts on fire. But when atoms of chlorine and sodium combine, filling the outer electron shells of both atoms, they form a common substance that you use every day. The common substance is halite, or as we call it, table salt, NaCl. So they also show you bromine here and iodine. Carbon is a nonmetal that is essential to living things. So compare raw diamonds, those are raw diamonds, to the more refined final product. Graphite is made of carbon, exactly the same element as diamonds, but it looks and behaves differently. So this is pure carbon. This is pure carbon. This is what's inside the pencil. So it's not lead, it's graphite, and that's what we use to write. Graphite is made of carbon, exactly the same element as diamonds, but it looks and behaves differently. Carbon is a nonmetal that is essential to living things. Carbon on Earth is found in both elemental form and in many compounds. There are several different allotropes of elemental carbon. Allotropes are different forms of an element. For example, the graphite that is found in your pencil is composed of carbon. Diamonds that are used in jewelry and for industrial uses are also carbon. They have the same composition, but very different properties. Buckyballs are a more modern, laboratory-created allotrope of carbon. All right, so let's stop for a second. If we look at this, every black dot is a carbon, and the lines in between show the bonds between them. So when we think about elemental carbon, we think of graphite, which occurs in sheets like this, and that's why it slides off onto your paper. Or we think of diamonds, but they learned about a Buckminster fullerene, or buckyball, which is the carbons arranged like this. So you are welcome to read more about them. If you find anything interesting that you want to share with me, I'd love to hear it. But otherwise, yeah. Carbon is found in Earth's atmosphere in the form of carbon dioxide, CO2, and carbon monoxide, CO. Carbon is a main component of fossil fuels that we use every day. Petroleum, coal, and natural gas are examples of hydrocarbons, compounds formed solely or only out of carbon and hydrogen. And actually, just to stop for a minute, carbon is so amazing that there is an entire branch of chemistry called organic chemistry, which we'll talk a little bit about later. And the whole branch of organic chemistry has only to do with carbon. There are people whose entire job is just studying one aspect of carbon. It's crazy amazing. All right, argon is the most abundant noble gas. Argon is a nonmetal and a noble gas that is found in our atmosphere. In fact, nearly 1% of the Earth's atmosphere is argon. The word argon comes from the Greek word for lazy. Argon got its name early on because scientists determined that this element does not form any compounds. The discovery of argon in 1894 led to the realization that a whole new group of elements with similar properties existed. That was when scientists began their hunt for the other noble gases. Argon is used in the development of lasers. A noble surprise. Scientists originally thought that noble gases did not form compounds, something that other nonmetals commonly do. But in 1962, scientists discovered that xenon and krypton do form compounds with fluorine. They do so only under specific laboratory conditions. So overall, we're fine with saying the noble gases don't react, but of course scientists are always trying to discover new things, and they discover that they can basically make them bond with fluorine because fluorine is so reactive. Nonmetals lack properties but are distinctly not metals. As you've seen, nonmetals are found everywhere in Earth's crust, in our atmosphere, even in our own bodies. But it is difficult to come up with a set of properties or characteristics that define nonmetals. Nonmetals may form compounds readily, or they can be very stable, the noble gases. Nonmetals may be gaseous or they may be solids. It is important to realize that nonmetals may best be defined by what they are not, rather than what they are. So, properties. They are dull, not malleable, not ductile, do not conduct heat and electricity, and they're in the right side of the periodic table, except of course for hydrogen, which is way on the left. All right, so for our notes for this one, I kept the first paragraph and the goals. And keyword and pronunciation, we just have nonmetals. Elements on the right-hand side of the periodic table, except hydrogen, which is in group 1A. Why? Because hydrogen has one valence electron. Other characteristics, I should probably write that on there for us, huh? Characteristics of nonmetals include they are dull, they are brittle, they are not malleable, not ductile, not conductive. Some are very reactive like halogens, which is group 7A, which have 7 valence electrons and really want more for a full outer shell to be stable. So that is why they're so reactive. Other nonmetals, like the noble gases, do not react because they already have a full outer shell. There we go. All right, that's it for this lesson. When you're ready, go ahead and take your quiz. Bye.